This video is on topic 17, graphing rational functions. We're going to start with example number 2. So the first thing we want to find are the asymptotes, the vertical and horizontal asymptotes. So the vertical asymptote we find by setting the denominator equal to 0. So in this case, x just equals 0. We don't have to solve anything, it's already solved for us, x equals 0. And that is going to be the line that is the y-axis. X equals 0 goes through the point 0, 0 on the x-axis, so it's vertical. Horizontal asymptote we find by taking whatever our k is. So it's y equals 2. Whenever we have a number that's added to the right like that, that is your horizontal asymptote. It's just like our upward shifting when we had parabolas, when we talked about absolute value, that upward shift up 2. So horizontal means it's a left to right line. Y equals 2 looks like that. Next thing we want to do is find our zeros. So that's going to be when y equals 0. So we look into our table, which we can do on the calculator. So this is the graph of our function. We're going to hit second trace, number 2, 0, and we're trying to find this point right here. So I need to go to the left of it, hit enter, scroll to the right of it, make sure we're definitely past that point, hit enter. You can go back and guess if you really want to. And we hit enter one more time, and there it is, 1.5. We found the 0 to be 1.5, so I'm going to put that as an ordered pair, and then actually go plot that on our graph. And then let's find some more points using our calculator as well. So we go to y equals, and we're going to type in the function that we're given. Make sure you use your alpha y equals to pull that fraction up. And then we go to zoom 6 to graph it. So notice my asymptotes here that we already found. Now I go to second graph to find the table. And we want some points before and after the asymptote. So these are the points we found from our calculator, and I'm going to go and put these on the graph to the right. So notice that we have this graph over here on the left. It's above our horizontal asymptote and to the left of our vertical, and then on the right we're below the horizontal asymptote and to the right of the vertical. We always want to have 2 points to the left of the vertical asymptote and 2 points to the right so that you have enough of a shape of what's going on here. Now let's talk about domain and range. So the domain is everything from left to right, but notice how our graph is cut right here. It doesn't actually continue from left to right forever and ever. So it's not quite negative infinity to positive infinity. It's going to be negative infinity until our asymptote, which we know to be at 0 because we found it earlier. And then it's everything from 0 to positive infinity. I have to use these parentheses because if we put brackets here, we would be saying including 0, but it doesn't get to be at 0. That's blocked off right here. The graph stops. For the range, we're going bottom to top, so we're thinking bottoms up. Does this continue from negative infinity up to positive infinity? And the answer is no, it's cut right here. So it exists everywhere below our horizontal asymptote and everywhere above our horizontal asymptote, but not at the horizontal asymptote. So again, it's going to be negative infinity up until 2, because that's the horizontal value, and then 2 to infinity. Next up, let's talk about end behavior. So what's nice about end behavior is if you can find the horizontal asymptote, you could probably find the end behavior, because end behavior is talking as we go to the right forever, if we talk about x approaching infinity. So as we go right forever, we're approaching the asymptote. It's trying really hard to be that horizontal asymptote at 2. And as we go left forever, if we were to follow this forever and ever and ever, it's never going to drop below the asymptote. It's just going to keep getting closer and closer, super, super close to the asymptote, but never quite at it. So we found our asymptote. That means we found our end behavior. There it is. Example 4 looks a little bit different than example 2. What we're going to do differently is very little. We're going to start by finding our vertical asymptote by setting our denominator equal to 0. This one's just a little bit harder though. The last one was not quite as crazy. So we have 2x minus 6 equals 0. Now I'm going to solve this. So I add 6 to both sides. We get 2x equals 6. Divide by 2. So x equals 3 is going to be our vertical asymptote. So I'm going to go put that on our line. Next, we want to find the horizontal asymptote, and in this case, it's not quite just the whatever's being added to it, because there's nothing being added to it. In this case, we have to follow our rules. Because we have the same degree on top and bottom, we have an x divided by 2x. There's no squareds, there's no cubes. We're going to write y equals the coefficients. So it's whatever's in front of your x. And in the top, there's just an x there. That means it's 1x. And then in the bottom, we have 2x. So our horizontal asymptote is y equals 1/2. So now I'm going to put these two lines on our graph. The vertical one at x equals 3, it is crossing the x-axis at 3. That's how we can graph that. And then the horizontal one is going to cross the y-axis at 1/2. So this is a little bit tricky because it's not on a line that we can see, not on a grid line. But there it is, horizontal y equals 1/2. Next we want to find our zeros. So to find zeros, we can use our calculator. So first we're going to type this in using alpha y equals. Put the function exactly as you see it. And then we'll go to our graph. We got two curves. Notice the asymptotes stopping it. And then I'll go to my table. So the error is where our asymptote exists. We want some points before and after it. Dots, we'll have one curve that's going along the first group there, and another up here. Now notice it always hugs the asymptote. That is on purpose. It should get as close as possible to the horizontal asymptote and the vertical asymptote at your endpoints. So it's getting close up there, close down here. That's how rational functions behave, because they're driven by the asymptotes. So next up, we want to find the domain and range. So domain from left to right. We're talking, does it go all the way from negative infinity to positive infinity? And it's cut right here at the vertical asymptote of 3. So our domain is negative infinity to 3 and 3 to infinity. It's everything but that point there. And then the range is bottoms up. Does it exist from negative infinity until positive infinity? Nope, it's cut right here at our horizontal asymptote of 1/2. So we go from negative infinity to 1/2, and from 1/2 to infinity. Lastly, our end behavior. As we go to positive infinity, we are approaching our horizontal asymptote, which is 1/2. And as we go to negative infinity, we are approaching again our horizontal asymptote of 1/2.